All right, what we're doing today is Easy 3 Locator Plus testing. It's non-volumetric tank tightness testing. The test method is vacuum. It tests to a leak rate of 0.1 gallon per hour with a positive detection and 100% of a positive false analysis of 1.6%. That's the percent of false alarm. So the first thing we have to do is we're testing two 10,000 gallon heating oil tanks. We're doing the Easy 3 test. It's real simple. You take this blower motor, you isolate the vent pipe, you isolate your supply and return piping, and you put the tank under vacuum pressure. When the tank's under vacuum pressure, it's a 5-minute test, and we listen with a sensor. It fails if there's either a bubble or a hiss. A bubble would indicate groundwater coming in the tank or air coming in the tank raising up through the product level, and it would go bloop, 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 bloop. Or a hiss would represent a leak in the top of the tank, like a hole in it, where air was coming in. Therefore, when the tank's under vacuum, it would go tss, and you'd hear the air. So we're doing a vacuum test, but it's also combined with listening. So we're gonna have on headphones, we're gonna be listening, and we're listening for a bubble or a hiss. All right, guys, so these are the vent pipes right here. They're kind of sad, but these are them. We have to isolate them from the tank while we're testing it. We also want to make sure that when we're under test pressure that these tanks aren't manifolded, that these vent pipes are not connected to each other. In a perfect world, we're only testing the tank today, guys. We're not testing the vents. But because we don't have access to the vent extractors, we can't put in downspout plugs. We're forced to plug it here at the vent. I don't have two 4-inch NPT plugs to go in here, so we can make this happen by inserting in an expandable ball, a plumber's plug, and blowing it up. What we're trying to do is get this tank ready to put it under vacuum. This particular tank is a heating oil tank, so we have some concerns with the supply and return piping. If we don't isolate the supply and return piping, when the tank goes under vacuum pressure, the product inside the supply piping could drip back into the tank or could hiss back into the tank, and it could cause us to hear the bubbles and the hiss and think the tank's leaking when it's actually not. So what you have to do to prevent this from happening is you have to isolate the supply and return lines. You do that by either plugging or capping them, or in a perfect scenario, you shut the ball valves off if they exist. We've come down to the basement here. We were looking for a leak monitor. There is no leak monitor here. What there are, it's two petrometer gauges. These essentially, you pump them up and they show the level of fuel in the gauge by the staining in these gauges. As you can see, these gauges look like they're empty. That's because the tanks are more so on the empty side. We got two tanks outside. These are their supply and return piping that are coming in. We've determined that there's a series of ball valves, and instead of going through all the extensive labor of isolating and taking apart these fittings at the 2-inch unions and plugging and capping them, we'd have to plug and cap here, then plug and cap there. Liquid would drain back on us. We're gonna try to just shut these ball valves off and isolate the supply and return lines first, doing the quickest, fastest, easiest method. So what we gotta do is, now that the ball valves are shut, we gotta get outside, get the tank under vacuum, and do the 5-minute test on each tank and see if they pass. Now we have to stick the tank. We have to stick the tank for two things. We need to know the water level as well as the height of the product. So what I'm gonna do is I'm gonna put some water finding paste on. So I'm gonna put about 3 inches of water paste on here. I'm gonna stick it in tank 1, and we're gonna find out how much water's in the tank and how much fuel. So we've got 69.5 inches of product. Then as we can see that there's no water on the water paste. You can see very little purple staining here, but that's not enough to even say there's water. So we're gonna say that this tank has no water at all, and it's got 69.5 inches of product in it. All right, guys, we're lowering our tree into our riser pipe. This tape right here would represent grade right here. Grade is where I'm standing. You want to get this in you want to be real careful. You don't want to get that microphone in the water in the bucket. We're going to lower in here. Got our test tree going in. This tank wants to be right here. All right, guys, we've got the tree inside. What we have to do now is the baseline acoustic test. What that is we want to establish a baseline without there being vacuum added to the tank. Now that we have our test tree in, we want to come over here to our acoustical processor. We've plugged it in. We've plugged in the headphones. You want to turn it on. It's very important that you see this line on the volume. You want it to be between the M and the E. So we're going to turn that so the volume's between the M and the E. And now what we want to do is grab our headphones and we're listening. What I'm doing is I'm establishing a baseline. I'm listening for sounds that are currently occurring in the tank that are going to be intensified once it's under vacuum. And what I'm trying to do is determine the normal sound of the tank and compare it to the sound when the tank is under vacuum. And what I don't want to do is let the normal sounds inside the tank fight so much with me with the results that we actually hear. Make sure our grommets are tight. Grommets are tight. We're going to come over here. We're going to turn the blower on, get the cord out, plug it in. As you can hear, our exhaust is coming out of the pipe. As you can see, we just shut her down. She's holding pretty good at 2 inches of vacuum, but we're going to turn her back on and continue drawing some vacuum. We're not going to exceed 4. We'll make sure we don't pull more than 4 inches. We're watching both of our gauges. And we're trying to get this magic number up to our test pressure of 2.65 inches. Remember, guys, this test isn't so much on these numbers. This is an acoustic test. These numbers are just aids to navigation. Remember, this goes way into the thousands. So the fact that this isn't dropping, it's dropping a little, that's very minimal. This is representative, somewhat of a tight tank. Even though you see this dropping, don't get alarmed. Get alarmed when you see the 7 turning into a 6, turning into a 5, or you see this 2 turning into a 1. So what we're gonna do now, we started our test. We're gonna turn on our microphone. We're going to take it to the M and the E, and now we're going to listen. Okay, I'm hearing some air right away coming in, so we're going to look around for various areas where the air may be coming in. All right, guys, so we went down in the basement. We found, we had some what we thought initially was radio frequency interference. We went downstairs to investigate. We found all of our ball valves tight. We found it leaking at the petrometer. We put in an 1/8 inch plug, and we're back out here. Amazingly enough, we didn't lose much at all for test pressure. When we came back out here, we installed that plug. Everything was still at a testable point. So all that frequency we heard, as you put on the headphones, now you can't hear anything. It's still. Remember, I'm listening for a bubble or a hiss. A bubble would be air or water coming in from the bottom, working itself through the 78 inches of product, going blub, 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 blub. Or a hiss would be a sound from maybe a loose fitting here, or a loose fitting on the tank on the top of the tank. You could also have an erroneous bubble or a hiss, which would be non-representative of the tank. And that could be because of tank top components. But we know on this tank top, there's not many components. We went down, we didn't hear the bubble or the hiss with the supply and return piping. When you hear a bubble or a hiss, you don't immediately run and blame it on the tank. You want to first try to troubleshoot things and get things tight yourself. You know, I could have said that the tank was failing because it was hissing. It was giving an RF frequency, which was reminiscent of a hiss. I could have failed it, but if I would have done that, it would have been inaccurate. This tank is tight. It wasn't failed, so you had to do some troubleshooting. This tank is tight. We've ran a 5-minute test. It hasn't dropped much. We don't hear a bubble or a hiss. This tank is tight, it passes. So we put in our expandable ball and it worked out well. We're gonna relieve the pressure now. We already opened this valve. We had 5 of them. We're gonna open, our test is done. We're gonna put this sight back to the condition it was when we found it. Okay. The 4th one open. All right, guys, if we switch our attention over here to the petrometer. These were the petrometers. This was the one that was initially leaking. Because it was so quick, it cost so much time when we pressurized the tank with vacuum to find this. We weren't gonna wait for this gauge, which is also in a pretty poor condition, to leak just like this one did. So we cut out the middleman, and we also capped this when we tested the second tank. We capped it prior to testing it because it was so quick to cap it, and we assumed a 80% chance it was gonna leak. So we capped it, we rolled the dice, and wouldn't you know, the test on the second tank passed immediately. So I believe it was a good bet, but sometimes you gotta think ahead, think outside the bun, and do what it takes to get the job done correctly, but as fast as possible.